In this video, we would like to examine the combined effect of opening new retail outlets and closing existing ones. Let's first look at the necessary spreadsheet data before opening a new project in LITIC. All retail-related data with their units are stored in multiple sheets. The first sheet shows region-related data such as latitude, longitude and sales value. The next sheet shows data related to outlets, including outlet cost and a reference to existing outlets. The last two sheets provide the driving time in minutes between regions and outlets, and between every pair of outlets. Next, we start with opening a new project in LITIC and import the spreadsheet. As a result, all spreadsheet data is now available inside the project. We are now ready to build an optimization model to analyze the existing retail footprint. First, we select the output that we would like the solver to produce. The main decisions are to select outlets, and assigning regions to these outlets. Next, we select total net revenue as the objective to be maximized. From here on, we specify the requirements that model the retail footprint. First, we need to indicate how total net revenue is determined. As you can see, building a requirement is just a matter of drag and drop. The first term will determine total revenue. While the second term determine the total outlet handling cost. The second requirement will make sure that each region is assigned to at most one outlet. We next list all remaining requirements in order to save time. The third requirement states that customers in a region have a limit on how long they need to drive. The next requirement is a technical one, stating that a region can only be assigned to an outlet if that outlet is selected. The fifth requirement wants to make sure that nearby outlet locations are not selected. The last two requirements allow us to analyze the effect of opening and closing outlets. At this point, we would like to just open up all the requirements to give you an impression. Understanding them in detail is not the purpose of this video. It is time to solve the model and look at the results. Our main goal is to analyze changes in the footprint, and that's why we will next build a what-if experiment. It is straightforward to specify the scenarios that considered opening and closing retail outlets. In this case, we will examine 9 scenarios combining 3 opening alternatives and 3 closing alternatives. We are mainly interested in the values of the outlet selection and total net revenue for each scenario. We quickly build a procedure that executes the optimization model, and use it as the main procedure. Just click on the Run button, and examine the total net revenue for each of the 9 scenarios. Note that the solutions are ranked for a quick inspection. Solutions 1 and 2 are almost equivalent in terms of total revenue and the number of selected outlets. Some more detail is provided on the next sheet when comparing any 2 scenarios. Let's select Solution 1 on the left, and Solution 2 on the right. Solution 1 is clearly preferable as it will require only 1 instead of 2 new outlets to be opened. The Northeast 80th Street outlet will then grow more than the Alaskan Way Viaduct outlet will shrink. In conclusion, we would like to state that this simplified model can easily be extended to include more realistic detail. Just think of considering different customer purchasing characteristics for each region, or adding a requirement to only allow minimum size outlets, or including competitor information while searching for new locations. It is quite straightforward to incorporate such additional requirements when using the LITIC software.